So thanks for joining this talk on passwords and AI in authentication in Authenticate 2020 session. My name is Asad Ali, and with me I have Michael Hutchinson. Both of us are technologists in the Thales cybersecurity business unit based in Austin. Thales has had a long history of developing cutting-edge products in the authentication space and doing research on new form factors and how authentication has to be placed. And both of us are really glad to be here to talk about not only our experiences, but our insights into what this technology holds for us. So when we talk about passwords and authentication, the two words are considered synonymous. Ever since the advent of computers, whenever people talk about doing authentication, invariably passwords come into play. And the reason for that has been because they've been very simple. And as we'll talk about that, we'll trace the evolution of how passwords have evolved and what new authentication methods are going to take place. So in that context, we'll talk about the past trends, the present challenges or the current challenges, and what opportunities are there for the future. Now, I mentioned that people have used passwords, but at the same time, not everybody likes passwords. And in the past, people have tried to remove passwords from their authentication space. And one example of that is when Bill Gates was presenting at RSA 2004, the title of his talk, or what was published in the media, was that Gates predicts death of password. And this is in 2004. Now, one thing that he did mention was that there's no doubt that over time, people are going to use less and less password and rely less and less on that. So from that perspective, his prediction has been true, that there has been less and less reliance on passwords because people have tried to use additional form factors of authentication. But are they dead? Not really. So this was almost 16 years ago. And the question is, okay, well, how have things evolved since then? And Microsoft, in their recent Ignite conference, the one that occurred in 2018, they essentially have the same tagline, that in one of their presentations, they're saying they're declaring an end to the era of passwords. So over 2 decades have passed, and people have been trying to get rid of passwords, and that has still not happened. However, at this point, we feel that they may be at an inflection point where things are evolving at a faster pace, where we could see changes happening, and we've already seen changes happening. So before we talk about those changes, I'll hand over to Michael so that he can walk us through the evolution of passwords, what has happened, and then I'll come in and see, okay, well, what changes are in store for us in future, where we can rely on some of the AI concepts to make a change in how people use passwords. So with that said, Michael, over to you for a journey through the authentication space.
Thank you, Asad. So the evolution of passwords, I'm going to take you through kind of the hows and whys and wherefores of authentication. I think people kind of associate with 3 factors. Historically, things things you have, and things you are. So passwords, Q&A, started the authentication practices. We brought in the addition of devices that you carry around with you. So smart cards, OTP devices, pieces of hardware you actually carried around with you. This has kind of evolved in more modern days to be smartphone based, and now we're moving towards the new FIDO devices. So we have different bits of hardware that perform the same kind of features, but are implemented in a more easy to use and easier to deploy mechanism. Things you are. So traditionally that comes down to biometrics. So fingerprints, eye scans, facial recognition technologies. But we're now seeing new things of not just who you are, but what you are and what you do. So supplementary has come into play, where things are, I'm normally in these locations, I'm surrounded by these things, I do these kind of operations, I walk this way, I do things, I type on the keyboard. So there's supplementary things which are not necessarily scannable with a biometric device, but are obtained over time to see when I log in, what things do you have around you. So looking at the actual authentication methods themselves, so passwords hopefully are hashed on the server side. We've seen some examples in the past of some databases that have been hacked that show that some people aren't hashing their passwords, just even in straight hash words without even salting. The Q&A, similarly can be hashed to protect them. Smart cards traditionally are PKI with certificate-based authentications to prove the root of trust. OTP devices, they have HOTP oath kind of protocols behind them. But what we've seen with the rise of smartphones is the combination of all the prior technologies into one device, with the addition obviously of new biometrics as well. And the FIDO devices are using public key cryptography, usually without certificates, but can be certificates as well. In terms of biometrics, there are a myriad of basic technologies to solve how you obtain fingerprints, eye scans, and facial recognitions. And all of them are being utilized in some form or another. In terms of usability, generally speaking, as far as the user is concerned, passwords have lived in our environment for the decades, primarily because users like them. They're not necessarily the best solution, but they tend to be accepted by users because they have their one password that they use everywhere. It's not a good thing. The only thing they normally complain about is when the company or the enterprise enforces on them that they have to remember complicated passwords. Complicated passwords are intended to protect the system, but generally speaking, it means that the users have problems remembering them, and you're going into password resets all the time. So, but in terms of the ability to use a password, that's good. Q&A is problematic because if I forget my password that I'm using every day, the likelihood that I remember a password from 2 years ago that I entered that asked me who my favorite movie star was may have changed anyway. So the Q&A don't tend to be that great a solution. Smart cards, OTP devices, and even FIDO devices have an issue of availability. You have to have it with you. So those tend to be problematic in terms of I forgot it at home. I either have to go right back and get it, or I have to dumb my system down and go back to a lower level of protection. Smartphones, I've solved that problem in one way, is that nobody really leaves the house without their smartphone anymore. So as long as the technology of authentication is embedded in a smartphone, users really tend to like that solution. The things you are, generally speaking, you're bringing them with you, so you have them in in yourself, so you don't tend to forget them. Fingerprints, the scanners are good technology, but depending on your fingers sweat or any stuff that's on the scanner itself can be problematic. Facial recognition is basically a better solution in that the camera normally scans your face very fast and doesn't tend to get covered in any gunk or debris. Whereas eye scanners usually are affixed to a wall on a door entry or some high security area and haven't really propagated into the user space outside of physical buildings. So in terms of the strengths, this is kind of the corollary to the usability thing. In the passwords are known to the user because they use the same one everywhere, but that has the deficiency that once they're actually known by an attacker, he can go to all their sites and log in. So the strength of passwords and Q&A tends to be things that you post on Facebook anyway, so people would normally guess your answers. And the hashes, depending on how well they're protected, people can actually attack those by creating rainbow tables. With the things you have, they're better than the passwords on their own because it's something that you physically have, and as long as you have it in your possession, you know that person is going to be the person with the object is going to be the thing that logs you in, so that they're better in strength. But on the other side of that, not having a device, means that you may have to lower yourself down to a low level to get logged in anyway, or you may have to go through a redistribution of a device and re-enrollment, which tends to be annoying to the user. They can't log in during those periods. Hardware is better than software. And if someone comes along and takes your device off your desk and uses it to log in, it's still just as compromised. With the things you are, it's very difficult to steal someone's face. Most of the algorithms that we have nowadays do some kind of life test, either the blood pressure or the beating of the heartbeat. They check the fingerprints, and the faces need to move. You can't have a photograph. They do 3D analysis. So generally speaking, the biometrics are the best, and combining these things together into multi-factor authentication provides even better security. So going to the other part of the biometrics, the supplementary system. As an example, I'm going to give you an example of a device vicinity context. So once you're logging in to an application with your standard MFA technologies, it's possible for the system to look around you and see, either by automatically binding to the things that it can see, or asking the user to enroll and register the keyboard, the watch, the headphones, whatever things it can obtain in your close vicinity. And next time you log in, it can see if they're still there, and it can use these in a future authentication. So this is some of the new supplementary information that can be gathered during a successful authentication. But another aspect of authentication is the requirement that each authentication technology be connected to the back end through a channel. And each one of these channels is unique to the application and the technology being used. So it creates individual silos, and as new technologies are released, you have to then connect that new technology to the back end. Whereas if we look at the FIDO solution to this problem, what they've implemented in their standardization is that the actual local authentication is arbitrary, and it's up to you. It's up to the individual manufacturer of their devices as to how they want to authenticate locally, be it just touch, physical touch, biometric touch with an actual scan, or voice control, face it, and it depends on what technology they build into their local authentication. But once they're authenticated the device will connect to the back end in a standardized way, so that all these devices and any future DNA test that happens on the local device will use the same crypto protocol to connect into the back end. So looking back on Microsoft and their initial 2004 presentation. So in 2018 presentation that we referred to earlier, there was a promise that in 2018 they would come up with some public previews of passwordless technologies, including FIDO security keys. What they then came up with, 2019, they actually released and announced that they brought it to over 800 million active Windows 10 devices. So then they are moving forward, but this is in 2019. That's including Windows Hello, FIDO security keys, and mobile authenticator. They then moved forward again in 2020 and said that they'd implemented it with Azure. So that's going from the Windows 10 devices themselves out into the cloud. And again, with the same set of security devices, but they're still not passwordless. They're still moving forward with that technology and moving into the new world. And latest information I have is that they're up to 100 million people using that each month, has now moved up to 150 million people. They've added support to the individual applications rather than just the log on to the desktop. They're now supporting applications within the desktop. So they have some mentions here of Azure, Office, Xbox, GitHub as kind of web clients that they have access to. But they still don't have all of the applications. They haven't actually got to the point where passwords are not needed for the entirety of the Windows life. But they are still supporting the FIDO2 mechanisms. So with that all said, I'll hand it back over to Asad for him to talk through the AI portions of the presentation.
So thank you, and thanks, Michael, for that introduction on how the authentication has evolved over the years. So let's talk about how AI plays into this. And before we delve into AI, I think it's important to pay tribute to one of the founders of AI, Marvin Minsky. He was winner of the Turing Award given by ACM, and as I mentioned, a founder of AI, and not only AI, but he co-founded the AI laboratory at MIT and worked very closely and heavily at the MIT Media Lab. And one of the things that he used to tell his students at Media Lab at MIT was to devise something which they called the Minsky challenge. And the Minsky challenge was that, okay, well, build a machine that can differentiate a cat from a dog. And of course, in the early days of AI and computing, where the processing power was limited, this was a daunting task because you didn't have reams and reams of information and data to browse over. And this is where essentially AI started. I mean, of course, we have come a long way since then. And one of the changes that have happened is this cycle of money, research, and money. I mean, back in the early days when Minsky was working, money was essentially following research by investing in promising research. What we see now is somehow a flip side of that, where research seems to be following money by optimizing already proven sources of revenue. And that's what we see happening in the AI space and machine learning right now. So as we talk about AI and machine learning, let's get a deeper sense of what these actually mean. So in one way, when we talk about artificial intelligence, this is the general concept of creating algorithms and allowing machines to do things which can be considered as smart. And as I mentioned, I mean, Marvin Minsky was one of the pioneers of that, and that was more than 20 or 30 years ago. And to some, when they think about AI, I mean, it was old school. So perhaps a new term had to be coined. And this is from the marketing side, is where machine learning comes in. So when people talk about machine learning, it can be considered as a specific implementation of AI, where you give computers large volumes of data and then guide them to do something smart with it or make sense of that data. So this is essentially the definition of what we call machine learning. At the same time, there's a more focused concept that we call deep learning, which is in even a narrower form of machine learning, which essentially means that you don't have to guide the machines as much, which is the case in machine learning. But instead of it's unstructured data that you give to the machines, and you don't have to guide them. So that essentially is a deep learning algorithm, which makes decisions on its own. And whenever computers make decisions, the question is, well, how good are they? And this is what leads us to what we call the perils of AI or machine learning or deep learning. And here are some of the examples in which we currently use some form of AI, from college admissions to loan approvals to lodging and auto rental marketplace. So the question is that, well, how good are these predictions which are made? And they're as good as the data which is fed into them. And generally what we see is that data could be tainted because historically there had been some biases. So for instance, if you are predicting success in an enterprise or an organization, you may be inclined to give preference to white males, because when the algorithm looks at the success of current stakeholders or the current employees, they see that, well, white males are predominantly in the higher positions in the corporate ladder, and based upon that, the prediction which is given as a sense of success factor or success recommendation, that may be flawed. So this is one example of how AI could be flawed. Another example, which is pointed out by Gary Marcus in his book, is that, well, right now the software that we write does not deserve our trust. And what he's saying is that, and that's what is mentioned in the title of his book as well, that we need to reboot AI because we need to reestablish the trust. And the trust is not there because fundamentally software is not as human as we would like it to be as yet. Eventually, I mean, it will get there, but the question is that, well, is it there right now? And predominantly the answer is not yet. So these are the two fundamental things that we have to consider: the AI bias, which is based upon historical data, and the trust in the specific algorithms that we are writing, which may not be there. And a good example of that is what was published recently in the MIT Technology Review, where they mentioned that, well, a turtle could be fooled as a rifle. So essentially, if you're a drone or you're a robot with deep learning algorithm for vision, you may be inclined to think that, well, what you're looking at is a rifle, whereas in reality it's a turtle. And this is not something which is conjured up by a state-sponsored adversary. These were four guys at MIT who basically created this vision because they knew what the inside of the algorithm was, and based upon that, they can fool the algorithm. So we have this history of, well, what AI bias can do, what the trust in AI is, and how it can be fooled. And the question is, well, how do we move forward with that? What does it have to do with authentication? So all these examples which I gave you, they did not have the sense of authentication that we're currently dealing with. So let's talk about authentication. One way that people have tried to introduce AI, and with some success, and that success is of course getting better day by day, is this notion of what we call the device vicinity and the context of what people are currently doing. And this is in line with the current notion of zero trust, which has evolved over the years, over many years, and now it's becoming mainstream, which is that, well, don't trust the user for any actions, always verify. So not only that, don't trust but verify, but never trust and always verify. So that's the current model. And in that context and in that application, so let's go through an example of how this might work. So let's say that I'm sitting at my desk working on my computer. I have various devices around me. I may have a keyboard, which is a Bluetooth keyboard. I may have my headset, like the one which I'm wearing right now, which is a Bluetooth headset. I may have a mouse, which is a wireless mouse, and it's a Bluetooth mouse. So I have all this array of peripheral devices around my work environment. And the question is that, okay, well, can we develop an algorithm or an application which would, over time, make sense of what is it that I have around me when I work? And by doing so, essentially predict what the authentication method should be used, or if any authentication method is needed at all. And people have tried to do that through other sources, like, for instance, I mean, they may want to look at your IP address to see whether you're logging in from home or whether you're logging in from a corporate network. And based upon that, they give you different options for authentication. So this is, whereas in that case, those two are two discrete points, and you don't need an AI algorithm to work with that. All it is it's a policy, which is probably an if statement inside a code somewhere, which can make that determination. Whereas what we're talking about now in this context of devices which are in the vicinity, this is a bit more complex, and this is where AI comes in. So let's go through one example. So let's say attempt one is that I present my user ID, and the system looks around and say, okay, well, what are the map devices which I have, which I may rely on? And the answer is none. I don't have any map devices, but the system found that, well, there are 4 devices or 3 devices which are there. So D1, D2, and D4 are there. So maybe the mouse, the keyboard, and the headset is there. And in this case, they would say, okay, well, please enter your login and your password. And of course, we mentioned password here, but it could be any 2-factor or whatever is deemed necessary. In the second attempt, the same thing happens. And now the system says, okay, well, what do you have around you? And this time, again, there's no map device, but I have 4 devices. And so maybe I have my phone as well, which is in the vicinity. So that's the 4th device which is there. So over time, as I repeatedly log onto the system can learn. And over time, it would basically make a map of, okay, well, what are the things which Asad has around his environment when he's working, either from office or from home. And let's say at the nth attempt, it will say, aha, so I found that you have device 2, device 1, and device 3, and device 4, which I've considered as essential devices which you have around you. And I see that you have 3 of them already around you. So based upon this information, the system may say, well, you don't have to log in. Your indicating of your ID is enough. And again, this is an example. I mean, all of this could be considered as a policy. One policy could be that, well, you have to enter your password, but not the second factor. Or in this example, if the threshold is low, you may be allowed to log in directly. So this is an example of how AI could come in and facilitate the user's authentication experience. And the model here is that, well, recognize, don't authenticate. Where when we meet somebody, we just recognize them from their face instead of asking them for their details or their credentials. So this model is very similar to actually recognizing the users. So that brings us to what we feel the future could be. So we've seen the examples of how AI bias and others can disrupt or not be done correctly. And at the same time, we've seen example of, well, how you could use device proximity and as an AI tool to help authenticate the users. The way we see the future is that, okay, well, we'll get to that in what we call the trusted AI, which means that when you have trust in the software, when you have trust in each of those devices which I have around me, at that point, you can have a collective trusted AI, which will help us authenticate more, which means that in the case of the device, we have to make sure that, well, the software which is running on that device is secure. The connectivity between the device and the laptop which I have is secure. So no device can be spoofed or added in, which can disrupt that authentication flow. So with that in mind, the way we see that is that in the space of authentication, this is much easier done than all the other examples that we've seen where AI bias could be an issue. So if AI has to work, what we see is that authentication is the right frontier where we will see that happen and happen successfully. So with that said, I'll just give one last example of how we have seen things in science fiction. And sometimes science fiction of 20 years ago becomes the reality of today. And the Minority Report, which was a movie by Spielberg in 2002, is one example of that, where John Anderton is now recognized as Mr. Yakamoto, and rightly so, because he's just had an eye transplant. So back in 2002, this was science fiction, but we already see that iris recognition and scanning is becoming reality, and we are utilizing that in various fields. So just like this can become a reality after 20 years, what we see is that online authentication for users can equally become a reality with trusted AI. So with that, thank you very much, and thank you.